Okay, simplifying radical expressions. So I know it's in simplest form when I've met all of these three things. And there's different ways I can go about it in order to solve these. Now a lot of these things you've been doing for a while, but make sure you take note of where I'm getting the numbers. Okay? What I want you to see from this is you can break apart anything that's underneath the radical to these things. Now as a reminder, numbers you're looking for are perfect squares, so I've written those up here. So let's try the first example. So what I want to do is I want to simplify the square root of 54. Now, there's a couple ways to think about it. So some of you who have your math facts memorized better will be able to do this a lot quicker. So I'm going to show you two ways. First, if you know one of these perfect squares that divides into here, so like for instance, I know it's 9 times 2 times 3. Because 6 times 9, and so this is 9 and this is 6. Okay, so what I can do is the square root of 9 is 3, and that has to stay. So 3 times the square root of 6. That's one way of doing it. Another way to do it, if you can't think of those numbers, is to completely factor it. So this is completely factored. 3 times 3 times 3 times 2. So if I look at that, any pairs of numbers will go outside. So 3 square root of 6. So either way is good. You're looking for those perfect squares or a pair of numbers. Let's look at number 2. So I have to determine what goes into that. So I know that 9 goes into there and 20. But 20 I need to break down even further, so I'm going to use 9 times 4 times 5. So the only thing I have here are perfect square, and then 5 is a prime number, so I'm good. So the square root of 9 is 3, square root of 4 is 2, and I'm left with a 5. So it's 6, radical 5 is my answer. Now if you struggle finding that, then just completely factor out the number. So I'm thinking it's 18 times 10. 10 is 2 times 5. 18 is 3 times 3 times 2. So 9 times 2. Now I'm looking for pairs of numbers. Here's a pair of 3s and a pair of 2s. So you get 6 radical 5. Let's look at it with variables. So remember, with variables, they have x times x is equal to x squared, which means the square root of x squared is equal to x. So for 90, I have 9 times 10 x, 3 x's, so this is factored out, so I know this is 3, and the 10 is going to stay. I can break that down to 2 times 5, but that doesn't help me at all, so 10 will stay. I'm just looking for pairs. One pair of x's, 2 pairs of y's, two pairs of z's, and there's one left. So I didn't write that very well, but it's going to be 3x y squared z squared 10xz. So there's an extra z here and there's an extra x. Let's try another one. So I'm going to completely factor this out. So 32 is 8 times 4, and 8 is 2 times 4. So 2 times 4 times 4, so that's 32. And this is good because these are both perfect squares, and then 2 is a prime number. And then R, have 4 K's and then 5 Y's. Okay, so I'm just looking for my pairs. So the square root of, here's a pair of 4's, so I put a 4 out here. One pair of R's. 2 pairs of K. 2 pairs of Y. Left with 2Y. So remember, out here, this is the 4. Inside here, it would be 16, because the square root of 16 is 4. Alright, now we're talking about quotients with square roots. And of course, a quotient is a division problem, and so we have division here. So I'm going to change this to the square root of 35 over the square root of 15. You don't want to have any radicals in the denominator, so to take care of that, I multiply by square root of 15 over square root of 15. Now here's where it gets a little tricky. Hopefully you know by definition the square root of something multiplied by the square root of that same thing is the number. So that gives me 15. Square root of 15 times square root of 15 is 15. Here I have to multiply these. But instead of multiplying them and making it a big number, because I'm going to have to simplify it, I'm going to put all these numbers under the radical. So 35 is 7 times 5, and then 15 is 3 times 5. So here I have a pair of 5s. So I have 5 times the square root of 21 over 15. Because a pair of 5s came out here. And I can still reduce it even more, because 5 and 15 are both divisible by 5. So 5 goes into here once, and into here 3 times. So square root of 21 over 3. Let's try another one. Okay, I don't want any denominators with radicals, so I'm going to multiply by square root of 12 over the square root of 12. So denominator gives me 12. Any radical times the same thing is going to be 12. Then I have to break this down. 6 is 2 times 3. 12 is 4 times 3, so 4 is 2 times 2 times 3. Then a y. So I'm looking for any pairs that I have. Pair of 2's. Pair of 3's. We're left with 2y over 12. So it's 6 radical 2y over 12. And then of course I can reduce 6 over 12. It's 1 over 2. So square root of 2y over 2. Okay, let's look at using the conjugate. Now this is probably one of the more difficult parts, but to know how to start shouldn't be hard. If I look here in the denominator, I have 3 plus the square root of 5. So what I'm going to do is I'm just going to multiply by 3 minus the square root of 5 over 3 minus the square root of 5. Again, I'm not changing the value because I'm multiplying it by 1. Anything over itself is 1. Because this is a plus, these are minuses. So notice where I got this. It's called the conjugate. It just says this is plus, this is minus. So then you just do distributive property. So I have 9 minus 3 times the square root of 5. And then I have to do this, of course, twice. And that's 9. I don't need to have a middle term because 3 times negative square root of 5 is negative 3. This times positive is positive 3, radical 5. So those will cancel out. And it's minus 5. Now this, if you remember, we had difference of squares when we were factoring that. We also had the product of a sum and a difference when we talked about special products. That's where that comes from. So even if you don't remember it, it's pretty simple. It's going to be this times this, which is 9, minus this number with no radical. So equals 9 minus 3 radical 5 over 4. Is there any way I can reduce this? And I cannot. So that's my number. And then the last one, so I want to multiply it by 1. 2 plus radical 6. 2 plus radical 6. So 10 plus 5 radical 6 for 2 minus 6. And again, can't add these, they're not like terms. This has 5 radical 6, this is a 10. And divided by -4. Nothing that divides into all three of those numbers. So I'm done.